Do you remember the Newton's first law of motion from last year?
Inertia.
Yes.
Inertia, it's known as a law of inertia, but what it states? It states like this: if an object do not experience a net external force, yani if the resultant force or net force acting on an object is zero. First law of motion is defining this case, yani net force acting on an object. This object can move on a straight line path or can move on a circular path. It cannot move on a circular path by the time if it is moving zero. So net force, if it is acting on an object, is zero. So this is the case. Object will stay at rest if it is initially at rest, like that rock. You see that rock right here? So it stays there. Why? It remains at rest if it is initially at rest, because net force acting on this rock is equal to zero. It will stay here infinitely if somebody does not apply a force on this rock. So the first is this: if the net force acting on an object is equal to zero, what does it mean? Maybe there are no force acting on the object. Maybe there are several forces acting on the object by their resultant, their additions, their sum is zero. So resultant force acting on the object must be equal to zero. In this case, the object is at rest. So if it is initially at rest, it will remain at rest as it is. Second, the object is in motion. If object is in motion initially, it will continue moving with constant velocity. Yani, that is constant speed in a straight line path. So this is the second possibility. This is the first law of motion. Even this first law is referred as law of inertia, you learned last year. Because this first law states that in the absence of a net force, when there is no net force, the body preserves its state of motion, which means if it is at rest, it wants to stay at rest. If it is in motion, it wants to be in motion. Preserving its state of motion means this. So constant velocity, at rest, at rest. So it doesn't want to change its state. That is known as law of inertia. And these sentences are exactly from your 11th grade book. And as object's acceleration, because if net force is zero, acceleration must be also zero. So the object's acceleration is zero, or the change in object's velocity is zero. In short, tendency of an object not to accelerate is called inertia. We will talk about it in this section. Tendency of an object not to accelerate. Yeah, if it is at rest, it wants to stay at rest. If it is in motion, it wants to move with constant velocity. It doesn't move to change its velocity. So in short, tendency of an object not to accelerate is called inertia. Second law of motion is, I'm defining, if an object experiences a net external force, yani net force acting object will not be equal to zero, object will accelerate. So two types of acceleration we studied till now. One of them is on a straight line path, object can speeds up or slows down, as we studied at the beginning of the first lesson. As you see, this object is speeding up. So then there must be a net force which causes this object to accelerate. And I showed them at the beginning. So it's to the right, in the same direction of the change in velocity. This is the one of them. Object can speeds up or slows down on a straight line path. But a second thing we already learned, the object can change its direction of motion. If direction of the motion is changing, yes, there is also some net force must be acting on this object. And we define that force as what? For this car, centripetal force. So this car is changing direction by some force. That force is called centripetal force. And we learned that that force is always towards the center of the circular path. And we calculate the force by multiplying the acceleration and mass. Mass times acceleration is the sum of the force acting on this object. This is very famous equation of Newton's second law. And coming the most important part, Third law of motion. Every action has a reaction. So if two objects interact, this is the statement from 11th grade book, your 11th grade book. If two objects interacts, the magnitude of the force exerted on object 1 by object 2 is equal to the magnitude of the force simultaneously exerted on the object 2 by object 1. And these two forces are opposite in directions, like this. These are two stellar objects, which can be Earth and Moon. Earth and Moon attract each other with forces equal in magnitudes but opposite in directions. These forces are known as action-reaction pairs. In nature, it is not possible to create a force, a single force. Every time, forces are created in pairs. One force is called action, other is called reaction, and we say them action-reaction pairs. Yani şöyle bir şey yok. Earth is pulling the moon, but moon is not pulling the earth. No, there is no such thing. If Earth is pulling the moon, moon is pulling the earth. Even their magnitudes are equal. They are action-reaction pairs. Okay, you are pushing a refrigerator. You are pushing a refrigerator to the right. A refrigerator is also pushing you to the left. So these are also action-reaction forces, action-reaction pairs. Or you are using a hammer to insert a nail into a wall. So hammer is pushing the nail. Nail is giving reaction to the hammer. So action and reaction pairs. So there is no force in the nature, as I said, single force. It's impossible. If you apply a force on something, that thing is giving reaction to you in opposite direction, but equal in magnitudes. That's why we say for every action, there is an equal and opposite reactions. Equal in magnitude, but opposite in direction. Equal in magnitude, opposite in direction. Equal in magnitude, opposite in direction. The forces that the object exerts on each other are called action-reaction pairs. Action-reaction pairs. Briefly, action-reaction pairs are equal in magnitudes, opposite in directions, and acts on different objects. Yani if you say action force is on the moon, reaction force must be on the earth. If you say, think about the sun and earth, say this is the sun, this is the earth. If sun attracts the earth, so earth is also attracting the sun. If action is on the earth, reaction is on the sun. Think about this picture. If action is on the refrigerator, reaction is on your body. If the action is on the nail, reaction is on the hammer. So always action and reaction will be on different objects. Two objects are interacting, so action will be on one object, reaction will be on the second object. This is known as Newton's third law of motion. We are going to define now a very important force for the 12th grade, which this force is known as the normal force. Normal line means perpendicular line. Normal line means perpendicular line. Normal force in this case will be a perpendicular force, but perpendicular to what? Now we will learn it. Think about a TV on a table like this one. This is, even I don't use a television, so this is a television on a table. This is a table. This is a television on the table. So somebody says you draw the free body diagram for TV. You know what does free body diagram mean? Draw all forces acting on the television. Free body diagram means this. You are going to isolate the force from environment, and you will show only the forces acting on the television's body. Okay, this is what free diagram is. So now let's think about that. There is a television inside the room. Of course, there is Earth. This television is on the Earth, is it? So just we learned that. If Earth must be attracting this television, correct? Earth must be attracting this television. But we know that there is no single force in the universe. So if Earth is attracting this television, so television must be also attracting the Earth. Yes, it is. So Earth and television interacts with one another. A pair of forces acts on television and the Earth. So like this. This Earth is attracting television down. Oh, don't think that television cannot attract the Earth. Of course. Television is attracting the Earth in the opposite direction. These two forces are in opposite direction but equal in magnitude. Teacher, but television is falling down because Earth has so huge mass. That's why if mass is huge, acceleration is so small. That's why we see all television is falling down towards the Earth. And as I said, yeah, Earth is attracting the television. Television is also attracting the Earth. These are action-reaction pairs. One of them I said FG, the other one is FG prime. Next, television pushes the table. Television is pushing this table down. A table must be pushing the television up. So I'm going to say that television pushes the table with Fn prime down. So this table must be pushing the television with Fn up. So then these two are also action-reaction pairs. This Fn prime, they are action-reaction pairs. But one of them is on television, which is Fn, I said. Second one is on the table, which is Fn prime down. And then two forces act on television. Now, question was draw the free body diagram on TV because we right now care only the force acting on television. There are two forces acting on television. One of them is Fn acting up. The other one is Fg acting down. Two forces act on television. Gravitational force Fg by the Earth and reaction force Fn by the table. So then this reaction force by the table Fn is known as normal force. So if somebody asks you, what does normal force mean? Normal force is the reaction force between two action-reaction force between two interacting surfaces which are in contact. So normal force always exists between two objects which are in contact. You see that this television and this table are in contact? Yes. So there will be always a normal force between this television and this table. So because I am just dealing with the television, Fn will be away from the table, up in upward direction. Normal force always exists between two objects, but object must be in contact. Don't forget that. In contact. And this normal force always perpendicular to contact surface. Now look at the contact surface. Is it horizontal? Yes. In this case, normal force must be in vertical. Yes. So contact surface is horizontal. Yes. Normal force for table is in vertical. Yes. Normal force always perpendicular to contact surface. And think about this television right now because we are just drawing the free body diagram for TV. Fg is acting down towards the center of the Earth. Fn is acting up away from the table upward. So then these two forces are the forces acting on this television. But is your television is moving in your house? No, it's at rest. If it is at rest, what does it mean? The net force
zero.
Yeah, net force acting on the television must be equal to 0, which means Fn is balancing this Fg. Fn, this normal force, balances the gravitational force. So that's why these two forces must be equal in magnitude. Yes, Fn and Fg, they are equal in magnitude. So sum of them is equal to 0. That's why television is in place always. If one force is greater than the other one, so it's going to be starting accelerating in the direction of the greater force, but not. So which means, yes, these two forces are equal in magnitude. So then sum of them is equal to 0. It's the condition of equilibrium according to first law of motion. And this is what normal force is. One more force you have to be familiar is tension force. This is another problem. Tension force students are generally not familiar with tension force from the 11th grade, and we will meet it in 12th grade about them. In fact, you studied about the tension a little in the 10th grade. Uh, the force, like two people are pulling a rope you see here. And the force created in a rope, it can be a rope, it can be a string, it can be a spring, it can be a chain. A force created in a rope or in a chain due to stretching. So these two people are stretching, pulling this rope in opposite directions. So, and when they pull it in opposite directions, here along the string or along the rope, a force appears. This force is called tension force. Sometimes in the 11th, I checked your 10th grade book, it is written that tensile force. So when an object is stretched, a force is created on this object. So that force is named as tensile or tension force. But the important thing you should know is that this tension force acts on the hand on the left and also the hand on the right. So this tension force also acts on these two hands in pairs. So the one on the left, the force on the left hand is to the right. Yani this rope is pulling this hand, the hand on the left to the right, but the hand on the right is pulled to the left. F1 and F2, they are opposite in direction. As you see, I put negative sign. This negative sign indicates that, yes, these two forces are opposite in directions. But what about their magnitudes? Their magnitudes are equal. So F1 acting on this hand, F2 acting on that hand. So they will be equal in magnitude. So one more thing you should be aware about tension forces. So you are the first time maybe you saw such a force, but it is very important. In some questions you are going to meet these forces. We will continue studying the forces, which is very important for us. Next one is friction force. Friction force. In fact, there are two types of friction in physics. Maybe you studied last year this. One of them is called kinetic friction. Second one is called static friction. So do you know what is the difference between them? When we say as kinetic friction, when an object is moving, this is sometimes causing a confusion. So, in fact, kinetic friction is not the force acting on an object which is moving. It is the force acting on an object when an object is sliding or skidding. You know what does skid and slide mean? Think about an ice in this winter. You are skidding on the ice. I mean, you are on a surface and then you are moving. However, just these two surfaces are relatively moving each other. Like ice skater are skating on the ice. They don't walk. They skate. Or when you release like what? Let me say a block or an object on a surface, a rectangular block. It starts skidding. So surfaces must touch each other and then relatively they must move. I will talk about kinetic friction because this kinetic friction, in fact, is not defined as it is the force acting on an object which is moving. No, it is the friction force acting on an object which is relatively in motion, which is skidding on an object. For example, you are walking on the floor. Is there a kinetic friction force acting on your body by the ground? No, it's not. You are stepping on the ground and your leg is not skidding on the ground. It is fixed on it. When you step on the ground, your leg is just on the ground. It's not skidding. And then you step another step, it's not skidding. If there is no skidding, there is no sliding. We don't talk about the kinetic friction. So now I will first define the static friction to you. Then I will go back to the kinetic friction by I will show some the demonstrations on my table by using my cell phone. First, let's study the static friction. Yes, static friction, you correctly said that. So this block is at rest in here. We know that if an object is at rest in like this, there will be two forces acting on this object. One force is, as usual, gravitational force. Earth is attracting this object down like this. Second force is The normal force, because this surface on which the object flows, and the X applies a force which is reaction force, and this reaction force is called normal force, and then this normal force and Fg are two forces always acts on an object which is on a surface. And surfaces in here horizontal, contact surfaces in horizontal, and normal force will be in vertical. And if we try to pull this object to the right, so you hold the object from this point and you start this object pulling to the right. But you observe that even you are pulling it like a table at home, you are pulling it to the right, but it's not coming. It's not moving. So when you pull this object to the right with a force applying by a force F, and if this object is not coming to the right in the direction of this force, you can easily predict that there must be a fourth force which stops this object being to be in motion. That fourth force must be named as friction force, which is between this surface and this object. And this force is known as static friction force. This force is called static friction force because it acts when object is not skidding on the surface. Object is at rest. Object is at rest relative to that surface. It is not skidding to the right. It's not skidding to the left, or it's just in place. So this is what static friction is. Right, and let me ask like this. Is there a static friction force acting on this object in this figure according to this diagram?
No.
Because you are not pulling it. Yeah, that's the point. You didn't start pulling this object. If you don't pull this object, so there will be no static friction, which means static friction force appears when you start this object pulling in one direction or pushing in one direction. So I start this object pulling to the right. So that's why static friction appears to the left. But surprisingly, this static friction force is not constant. So if you pull this object with one, static friction force becomes 1 Newton. If you start pulling with 2, it becomes 2 Newton. So they balance each other. When you increase the force and then pull with 3, it becomes 3, 4, 4. But static friction force can have only a maximum value. So it can increase 0, 0, 1, 1, 2, 2, 4, 3, 3, 4, 4, but it can get a maximum value. So that maximum value will be calculated. Static friction force, maximum value of the static friction force between two surfaces can be calculated by an equation. So this equation is Fs, static friction force, is equal to mu s multiplied by Fn. This mu s is called coefficient of static friction, and this number, it's just a pure number like 1, like 2, 1.5, 2.5, 0.5. This number is changing depending on type of the surface. I mean, so this is what kind of surface object is this and what kind of surface is that. So this coefficient mu s depends on the type of the surface which are in contact. And this static friction force is always parallel to contact surface. So this is the horizontal contact surface in here is horizontal. So static friction force always will also will be in horizontal. So it is always in opposite direction of the tendency of the skidding object. Normally, when you apply this force, what do you expect object to move? In which direction you expect object to be moving? To the right. That's why static friction force must be to the left. So it is always in the opposite direction of tendency of the skidding of the object.